All right, we're going to switch modes a little bit from equations and we're going to move into something called inequalities. So this is our lesson on inequalities. Go ahead and get your notes page set up. Remember to always give your title right across the top. Our learning target, here we're learning about inequalities and how to make them a true statement, and then our I can statement. All right, so far we've been talking about equations. So an example here is x plus 5 is equal to 13. The nice part about equations is there's one right answer. No ifs, ands, or buts about it. There's only one thing that's going to make this true. It's basically asking what number can I add 5 to and get 13 for an answer. Well, I can try all kinds of different numbers. I could put in a 4. 4 plus 5 is not equal to 13. So 4 doesn't work. I can try a 5. 5 plus 5 is 10. Definitely not equal to 13. In this case, there's only one answer, and that's 8. Because 8 plus 5 really does give me 13 as an answer. There's just one thing that works. Today we're going to talk about something called inequalities. An inequality is something that has lots of answers, okay? Which means we have to take care of all the possible answers as opposed to just thinking about maybe just one answer. So our example down here, we would read this as x, so some number, is less than 3. Well, I can think of a lot of things that are less than 3. 2 is less than 3. 1 is less than 3. 0 is less than 3. Negative 5 is less than 3. Negative 10 is less than 3. If my number line went out to negative 1,000, that's less than 3. All of these numbers are solutions to our inequality. It's not looking for just one thing, it's just looking for anything less than 3. I could even go as far as 2.5 or 2.6 or 2.9999999. That's really close to 3, but it's still less than 3. So the big part for today is that an inequality has a lot of answers. It has a lot of solutions. In fact, in some cases, it has an infinite number of solutions. So we're not just looking for one answer anymore. We're looking for what range of numbers would make this inequality true. All right, before we get started, we need to get some vocabulary and kind of get a handle on our symbols that we're going to be using here. So we're going to go ahead and make a little chart here in our notes. This first one, up top, a little too far, is the less than symbol. I think of it as less than. I kind of think of it as how would you draw an L? That's less than. It looks kind of like an L that's been kind of scrunched down a little bit. Okay, but less than, we could read this as 3 less than 5. Sometimes in a problem, you might also hear where it says fewer than, but it just means a number smaller than another one. So 3 is less than 5. So this symbol means less than. Next to it, we have greater than. Okay? A good way to remember it is the open part of the symbol is always opening up towards the larger number. So when we see this symbol, it means the number on the left is greater than the number on the right. So in this example, 8 is greater than 4. In a word problem, you'll see the word greater than, or you might see more than being used. But this symbol, when it opens to the left, when it opens up wide going left, we call that the greater than symbol. Now we have two more versions. You'll notice it's the same symbols, but now it has a little bit of line underneath of it. Basically, this is a combination of both our inequality and an equal sign being put together. So this first one is called less than or equal to. So now we're okay with it being two different things. We're okay with the number being smaller than our number, or we're also okay with the number being exactly the same as our number. So we would read this one as 7 is less than or equal to 10. Well, that's true. 7 is less than or equal to. It just has to meet one of those two criteria. Another word you might see used in a problem is if it says at most. That means it can be smaller than the number. It can be that actual number, but it can't be any bigger than that. It has to be less than or equal to our number. And then we have greater than or equal to. Okay? This means it's okay for the number to be larger than our number. It's okay for it to be equal to our number, but we don't want anything smaller. Another term might be at least. That's kind of putting a minimum on what it could be. It can be this number or it could be greater than that. But take a couple minutes, put this information into your notes. Make a nice little chart. It'll be something easy to refer back to as we're working on problems. If you have a hard time remembering which one's less than or greater than, or kind of how to use them within a problem. All right, so let's go ahead and put this to use. Okay, now we're actually going to see what numbers do work in an inequality. So here we have the inequality, f plus 2. So into some number, when I add 2 to it, I want it to still be less than 9. So one way to do it is to actually go ahead and check your solutions. So first we want to check the number 5. So we're going to plug in 5 for f. 5 plus 2. We want to know, is that less than 9? Well, 5 plus 2 is 7. Is 7 less than 9? Yeah. So 5 is one of our solutions. We check 6. Put in 6 for f. And yes, I want you to write out each problem and do the math to double check it. 6 plus 2 is 8. Is it true that 8 is less than 9? Yep, so we're good. Then we check 7. We plug in 7 in place of f. 7 plus 2 is less than 9. Well, 7 plus 2 is 9. Is it true that 9 is less than 9? In this case, no, that's not true. It's equal to 9, but that's not what the problem was asking. It wanted something less than 9. And then last, we'll check our 8. Plug in 8 for f. 8 plus 2. We want to know, is that less than 9? Well, 8 plus 2 is 10. Is 10 less than 9? No. So we know 7 and 8 both don't work in our problem. The only ones so far that we've checked are 5 and 6. They both, if I plugged them into my inequality, gave me a true statement. It told me something that is true. 7 really is less than 9. 8 is less than 9 when I plugged them in. So that's one way of checking your solutions is plug in several numbers, see which ones work and which ones don't. Remember, for an inequality, you're often going to have more than one possible solution. All right, so a little different problem here. Now, they're specifically giving us a possible solution. We want to know, does it work? Does it make it a true statement? So what we do is we plug it in, we see if it works. So x is equal to 8. So we're going to put in 8 for x, and we want to know, is 8 less than 13? That's how we'd read it. Well, 8 is less than 13. That's true, so we're good. Here, w plus 4. So some number plus 4 has to be greater than or equal to 6. Remember, it opens up towards the side where it's supposed to be larger. So w plus 4 needs to be greater than 6 or equal to. We want to see, would it work if I put in a 2 for w? So I rewrite it with 2 in place of my w. So 2 plus 4. Well, 2 plus 4 is 6. Is 6 greater than or equal to 6? All right. In this case, that is true. It's not greater than, but it is equal to. It just has to be one or the other. 6 is greater than or equal to 6. So we'd say yes. Last one, 3d is less than or equal to 18. We want to know, does that work if I plug in 8? Well, remember 3d means 3 times whatever d is. So 3 times 8. And we want to know, is that less than or equal to 18? 3 times 8 is 24. Is 24 less than or equal to 18? Well, clearly 24 is bigger than 18, so it can't be less than. So we would say, no, this is not a solution for us. So in some cases, we simply just want you to plug in a number and give it a try. All right, so now we've got the basics of our inequalities. That idea of what numbers are larger than it, what numbers are smaller. Okay, so now it's your turn. In your notes, your assignment is to answer these 3 questions. So for this first one here, it says, give me 5 different numbers that are a solution to this inequality. W is less than 2.5. So give me 5 different numbers that are less than 2.5. Then I want you to do this one here. Give me 4 different numbers that are a solution to this inequality. And I want you to read this one to yourself. Think about, am I looking for numbers bigger than 63 or smaller than 63? And then last, I want you to check, does 12, 13, or 14, is 12, 13, or 14 a solution to this inequality? So plug each one of them in for x, do the problem and see, is that number minus 6 really less than or equal to 7? It may be that none of them are a solution. It may be that all of them are. It may be that just 1 or 2 of them are. But I want to see that work and how did you check each of those solutions? Start to get an idea of what it means to work with an inequality.